So I'm really excited to be here. It's I believe, the fourth year I'm presenting in this conference. My presentation this year is fairly technical, and it's, guess what, about context, which really became the theme in this conference. More so in this morning, I believe in Robert Scoville's presentation, more than just context, but location seemed to be a key factor to drive context. I read the book, Age of Context, and that also recurring theme in that book. This is also the lens through which we look at the world. And so I want to share with you some of the technologies that will enable this type of services like were presented this morning. And maybe I should start with a story that happened to me a few weeks ago. I was at Toys R Us. If you have kids, you know what I'm talking about. You know the drill. You have to take the kid to a birthday, and guess what? There's no present. So on the way, you have to stop just for 20 minutes to grab something and keep running to the birthday. It was one of those events when I walk in, and they were able to distract me with this huge backyard wooden playset that my wife and me have been talking about getting one for the kids for, I guess, a year now. And it's spring, and it's like perfect timing. I liked it. I spent probably 5 minutes around that playset. Only problem is it was $800, and I was on a 20 minutes drive to get the present and run to the birthday, so obviously didn't make a purchase decision at this point. Unfortunately, I forgot about it, and only a week after I talking to my wife about this thing, and she's like, "Oh yeah, let's research." And there was a coupon. So we were researching this on Toys R Us, and there was actually a coupon for it, 20% discount. Problem is expired, and expired just 2 days ago, right? So when we talk about context, and when we talk about how to drive context and how to infer intent, location is a big thing, right? Because I spent 5 minutes next to this product. I mean, gosh, in the age of context, I'm expecting my phone, which is in my pocket, to know that, right? I'm 5 minutes in front of this product in that store. What am I doing, right? My intention is to buy it. Now, if you can help me, maybe give me reviews, maybe give me a coupon, and not necessarily in the store, maybe retargeting, right? Maybe retargeting in the evening when I'm in the sofa, 9 p.m., the kids are asleep, and I can make a decision. But, I mean, all this information is available. The question is how to source this and how to source it. And it's pretty difficult to do that. A lot of conversation about context and also messaging and how to message the right time based on intent. This is pretty difficult things to do. But turns out that using crowdsourcing, it's actually possible. And so this is what I came today to share with you. So, this is the technology that can actually enable this type of experiences. Now, SLAM became kind of a buzzword in the space. Last year, I presented this on stage. This is specifically large-scale SLAM. This is also the technology that is being used in Google Tango project. In fact, after the presentation last year, and by taking a look on the word that is mapping first to drive context, Google Tango approached us, and we are helping them to develop this technology on their Tango device. Now, what I really want to share with you is not so much about the technology, but how it can be used to drive context based on location. So this is another view of the same technology. This time, it's more of an indoor navigation type of view on the plot there. Now, what's happening in the background here, just to give a little bit of context about this technology, we are collecting accelerometer and gyro and camera measurements. And we are fusing them together to create accurate tracking of the location of the mobile device. That is done without, in this case, without having any information about this indoor space, about this stairway, and it still tracks with high accuracy. Now, a lot of these technologies have been demonstrated in the past in labs, but the last year, in fact, I demonstrated that last year at AWN. This last year was a lot about pushing this technology from what's possible on a PC and in labs to mobile devices. A lot of the credit has to go to Google Tango project because they've been funding a lot of that But now, it's becoming possible, and it's really exciting time for all of us because it's becoming possible not only for us, which we are developing this technology, so obviously lucky us, but also to all of you because this is becoming available for developers. And so, with that in mind, I want to now shift gears and talk about how this can be used for context in the indoors. So. The first step, right? The first step you need to do is to move it to a mass market device, right? The iPhone I have in my pocket, the Android that you have in your pocket. This is the first step, and so I want to show you a funny video that we created to demonstrate the robustness of this technology on iPhone. So this is what happens. My partner has this. Always jokes about this video because this is what happens when he leaves the PhDs in the office without adult supervision. This was an iPhone 5S, brand new, came to the office, we jumped on it, and throwing it through the room, you can see that, yes, it was tracking accurately the position and orientation of the phone, even though there was high motion, accelerometer and gyro were saturated, and the camera was obviously very blurry, as you probably know. So, with that in mind, knowing that it works on an iPhone, there still remains another test that needs to be done. This is working in the hands of, in this case, was Alex Flynn throwing the phone. He's a PhD in computer vision. And if you worked with one in the past, you know that computer vision guys have built-in smoothness in the way they do things with phones and cameras. So you really want to put it to the real test. And that's why I want to introduce you to Nolan. So, well, what I can say about Nolan. Nolan is a piece of art. He's an NYU student. He's working in our office, I guess, for more than 2 years now. He's the guy that walks in January, snowing outside, sandals and shorts, and he thinks it's warmish. So I guess the reason is from Minnesota, so he believes that New York City weather is actually awesome in the winter. He also likes to wear hats, and I'm not sure why, maybe to compensate for the sandals. But at the end of the day, what he likes most of all is to make some extra money. So we sent Nolan to a Home Depot. This is a large retail store. And he was holding a mobile device running our technology. And just to be clear, the blue trajectory being drawn was drawn on it's not using any information on this map, right? It's been drawn on a white canvas. And after the fact, we took it and overlaid on the Google map, being used here as ground truth for a sanity check, right? To see that this thing actually works on a very large sequence as someone is traveling in a large retail store. So this is what's happening here. And so we're getting to the interesting part because now that we know that accurate location tracking, right, position tracking is possible indoors without GPS, the question is how to take it from this level where it assumes the camera is always on, right? Because he's walking with the phone like that, and to the point where it's in his pocket, and it works for all of us without the assumption of the camera. And so this was pretty much the next step, and it turns out to be that it's possible. And the way we can do that is using RF signals, Wi-Fi and Bluetooth. So here is Nolan again. Now we send him to a Macy's store in Herald Square in New York City. This is another large retail store, but this time, more than just collecting, more than just knowing where he is when he walks with the phone like that, we also collect the RF signals, the Wi-Fi networks. In this case, we're plotting here one Wi-Fi network. I think in that specific store, there were more than 200 Wi-Fi networks. And so we are collecting enough to cover the entire store, obviously. And we are creating those maps. So sending Nolan or any one of you can go to a store now and map it such that it enables indoor positioning for the cases where the phone is not out, it's in the pocket. So to test this assumption, I want you to meet Josefine. So Josefine is a community manager in our office, and I think she's probably, well, definitely. She's the only one that that really leveraged the fact that we are in New York City, Spring Street, in the middle of Soho. So we sent her to to what she likes to do most, which is shopping, and she went back to Macy's. Sorry. Yeah, okay. She went back to Macy's. This time, she had a phone in her purse. There was no initialization required. There was no requirement. Just walk to Macy's, walk around with the phone in your purse. And now we can track her location very accurately in that store because on her phone, there's the map that Nolan pre-generated for that store, right? So when Nolan walks in the store, he's creating a map that has the structure, right, the floor plan, and has the RF signals. And with this, on her phone, using the accelerometer and gyro, again, we can track her location very accurately. More so, we ask Nolan to tell us where the jewelry is in that store, such that when Josefine is stopping next to the rings and examining those rings, we know, her phone, not we, but her phone knows she was there, right? And she has if she was there for 2 minutes, her intention at this point is to buy a ring. So Tiffany & Co. can send her a notification, an offer. Maybe a social media platform can send her a picture of her friend that was there a week ago, taking, measuring other rings and taking some pictures and posting them on Facebook. So this is the type of contextually based on location experiences that we can drive with this type of information. Now, if any one of you, right, can go in and map a store such that all the rest of you can enjoy this information to drive context, definitely Rosalind from TaskRabbit and many other people from that are interested to make some extra money can do that. And this is what we are currently doing, right? So people are going around mapping places such that all of us can go into those stores that are pre-mapped and enjoy contextual services that are based on our location, based on the time we spent in different places in those stores. So I think that, to wrap up and conclude this, I think that, if the last year was the year where, we've taken this technology together with Google Tango and internally as well, and moved it from labs into product. Right? This year, right, meaning so when we stand here next year and we talk again at next AWE, it's going to be the year where services are going to be introduced on this type of contextual information. And hopefully each one of you is going to enjoy this type of services that are highly targeted and know exactly what you want. So I think I'll pause here and open it for questions. Thank you very much.
Okay, so it looks like we have some questions. And awesome that you guys were tossing the phone around. That's
yeah.
So you mentioned about the new technology without the camera. You just use RF plus Bluetooth-based tracking. You also mentioned that you don't know the initial location. So how long do you need before you can actually triangulate a position and know? Like, how long should I be in the store for the store to know that I'm there?
Right. That's a really good question. So the way this works is that, well, it does know your location based on GPS, but this is very, very rough location because you're indoors. And that is enough to download to this phone the map that was pre-generated for that store. So once you walk in, pretty much the first turn you take, and it's good enough because every time you take a turn, it constrains the system enough such that we can then lock on your location. So pretty much the first turn is the time where we know where you are. And from that point on, we track your location all the way through the store. We're using the IMU data, obviously. Yes, yes.
Question, how precise is the positioning of the person?
Where is it? Oh, sorry. So in this example, actually, you didn't see the numbers, but the entire sequence was below 5 meters. But there's 80% chance that this is correct, meaning there's still a 20% chance that this is wrong. This is by the way, still in development. So this is pretty much the first kind of accuracy that we're getting. And we're definitely seeing cases also in some stores where it goes all the way to 2 meters. In other words, it's enough for for us to know which type of products your intention is directed toward.
And is it your equipment there, or just some Wi-Fi networks that you analyze?
Well, that's an excellent question. So and I know it's where you're coming from. So all the indoor positioning systems or solutions that are available today, at least the one that I know of, they either assume that the consumer is doing some friction, right? Is pointing the phone somewhere, is doing something to help localizing him initially and then tracking his location or her location, or it assumes that there's some infrastructure play between the device and the installed Wi-Fi, access points, Bluetooth, and iBeacon is just another example of those, right? This is the first time technology becomes available where there's no need there's no friction, not from the hardware infrastructure play, but also not from the user. This is totally crowd-based, scalable, without any requirement on the user or the store.
Thank you very much.
Okay, so any more questions? All right.
There's
up front?
There's one here.
Definitely.
Thank you. How do you know what products are in which area of the store? Is that something the stores have to voluntarily provide to you, or do you have to need to send an advance team in to figure out where everything is? I mean, you were talking about crowdsourcing. Obviously, the crowd can accomplish this if they're motivated in some way.
Yeah, that's exactly how it works.
I see. And another question I had was, for disabled individuals that have wheelchairs or canes, or they move about differently, their movement patterns are differently, you might want to consider other kinds of programs and things that might suggest to them things that they're interested in that may be closer, require less walking to a particular area or an exit or something like that to assist for ADA needs. So
you're actually raising a pretty interesting
helpful.
angle. You're actually raising a pretty interesting angle. Thank you for that.
Yeah.
And any other questions? And that is a good one, ADA approved AR apps.
Right. Thank you very much.
Yeah, well, thanks. And a big round of applause for all our speakers, please.